Hi, my name is Udo Slender. Welcome to my YouTube channel about adventures in astrophysics.
In this video, we will explore the question which details can still be seen in galaxies that are many millions of light years away. We will initially limit ourselves to globular clusters. In a further video, we will then look for other objects too. First we try it with our own eyes, then with the view through a telescope, and finally we use a highly sensitive camera as a detector. When we look up at the sky on a clear night, we recognize the dull shimmering band of our Milky Way next to several thousand stars. Spectacular to see as here on this picture, together with the companions of the Large and the Small Magellanian Cloud, which can only be seen south of the equator. The image was taken at the Paranal in Chile. Here is the Very Large Telescope of the ESO located. In this composite image the whole sky was photographed. You can see in this overall view that we live in a galaxy similar to this one, which is named NGC 891. The diameter of such galaxies is about 100,000 light-years. We ourselves are sitting in one of the spiral arms, about 26,000 light-years away from the center in a rather quiet area. The light of the 200 billion stars fades, but a lot of dust can be seen. Gas and dust are components of the interstellar matter from which stars are formed and which, in the course of their evolution with stellar winds and supernovae, also release matter back into interstellar space. Although it does not appear so, only 1% of this matter is bound in dust. With the naked eye, we can hardly recognize single objects in this system. Too small, too faint, so let's take a telescope.
I built this one 25 years ago. I got to know the sky with it, and I could tell you about many adventures I had in cold nights. The brightest deep sky object is the Orion Nebula, also known as Messier 42 or M42.
In other galaxies these gas and dust regions are good to photograph, but our eyes are not sensitive in this deep red region to observe them there with the telescope. The nearest large galaxy is M31, the Andromeda Galaxy. It is 2.5 million light-years away. It is found in the autumn sky near the prominent W of Cassiopeia. Here too, we see dust winding in bands along the spiral arms around the core region. Further on, we see two elliptical companions. M32 below the core region and NGC 205 at 2 o'clock. When we zoom into the galaxy, we see many details that make us curious. Among the bright objects of our galaxy are many of the nearly 200 globular clusters. Bright examples of them should also be visible in M31, although they are 100 times further away than M92, which is shown here. The problem lies in the much faster fading brightness of the objects. 100 times further out means 10,000 times fainter. This corresponds to 10 astronomical brightness classes. If we could move M92, which is 25,000 light-years away, into Andromeda, its apparent brightness of 6.3 mag would become a 10,000 times dimmer 16.3 mag. It would then be too faint for this telescope. But our largest, Omega Centauri fits. It would then be between 14 and 15 mag bright and thus still visible. The largest in Andromeda is twice the size of Omega Cen, and that is called Male 2 or G1, and it really has the computed brightness of 14 mag. The Hubble Space Telescope resolves them into individual stars, which should convince even doubters. As we just saw, even the large Male 2 remains star-shaped in our telescope. In the middle of the 90s, there was no internet as we know it today. Google, for example, only came to us in 1998. So back then, we had to rely on printed paper. Nevertheless, if we take a look at Paul Hodge's atlas from 1982 here, we will find dozens of other specimens that we can see with our own eyes through this telescope. There are also some in the Upper Companion NGC 205, but they are too faint here. Today, this is easier with the means of the virtual observatory. Well, not really, but with a few mouse clicks all known objects of the Andromeda Galaxy can be conjured up. Overwhelming, isn't it? Here are some labeled objects and details. On this picture only the globular clusters of M31 are marked. And here only the very bright ones that we can see with our own eyes through the telescope. We can only get further into the universe by taking pictures. Long exposure times, many pictures, and their processing in the computer have widened our view.
Here is my self-built CCD camera from the 1990s, when there were hardly any powerful digital cameras to buy. The chip was cooled very deeply to minimize image noise. Today, all this is no longer a problem.
The Sombrero Galaxy is 12 times more distant than Andromeda. The bright globular clusters are circled here, using catalog data. The following galaxies are a little further away. About 60 million light-years, so about 25 times more distant than the often shown M31. They all belong to the Virgo galaxy cluster, like the Sombrero and another 2,000 others.
The objects marked on the following pictures are some kind of spherical star clusters or core regions of former galaxies, which have been investigated in more detail only a few years ago. More about this on my website giga-parsec.de. Just search for M85. Like most of the pictures shown here, I also took these in my observatory. M87 has a supermassive black hole in the center which is 1,700 times bigger than the one in the center of our galaxy. It emits a blue jet 5,000 light-years long. I will discuss this in the next video.
The giant elliptical galaxy M87 sits in the center of the Virgo cluster. It has 100 times more globular clusters than our Milky Way. They can be seen in this contrast-enhanced image as a cloud of dots around the center. They have largely formed with other galaxies that M87 has incorporated over time. The foreign globular clusters live on in their halo. That we can still photograph so many of these objects at this distance is amazing. Thus we have come here 60 million light-years far. That means yes, that at the time, when this light started the way to us, the dinos were just extinct.
Have we reached the maximum distance for singularities in other galaxies? We will explore this question in one of the next videos. If you are interested, subscribe to this channel and give us a thumb.